Greetings and welcome to the first episode of the Lingering Nightmares video game and Devlog. This week we remade our interaction system to a modular, scalable and easy to implement event-based system. As of today, we have basic movement behavior for doors, basic UI for interaction texts, control of lights and emissive materials, as well as basic cinematics and even a basic inventory and pickup system. Finally, we switch our player and enemy controls to a finite state machine structure. We'll explain all of this coming up next. First, I will briefly explain how we used the previous system for our object interactions, what were the limitations or inconveniences, and a little bit of how it works and the reasons we decided to change it. Previously, we used to handle a unique code for each type of object interaction, so we had many specific codes that didn't offer or offer very little flexibility. For example, with the door, we had a general interaction code that was only responsible for storing when the player entered or exited the trigger area, that is this box, and will tell a more complex code the information of whether the player had entered or exited and what object the player was when he was inside. It also disabled the visual text at the moment the player exits the area. But this enable interaction code only worked with this specific code. So there was this dependency, and in the same way, you needed this code to enable the interaction open code. So in the end, they both depended on each other. The interact open code was responsible for making with the iTwin plugin, which is a plugin that takes care of making movements calculations simpler, and we highly recommend it. This is quite useful and free. Anyway, it was responsible for doing the rotation of the hinge with iTwin according to the animation time, stored if the door was open or closed, activate and disable the interaction texts, also ran the audio files based on the clip's directory path using the fmod audio engine, which is also another free plugin. Well, it had several different types of functions, and all of these only worked with this specific type of door. Either way, here is the code in case you want to use it as a reference. This is not a video tutorial. We still don't feel confident enough or skilled enough to do tutorials, but if you want, you can use it as a reference. Then it saved the variable on range, and if you were on range, you could interact with it. It triggers the player's animation. These are the rotation parameters. I will also put in the description the tutorials that we followed to get, or in which we use as reference to implement each of these functions, which are way easier to follow. We'll put them all in the description. Here the door opened, the texts were turned on and off depending on the state, and you also had the function that if the player exits, automatically the door could close, the closing audio clip will play, so we could reset the state of the door. The problem with these codes, just like the codes shown here in the lamp, for example, was that it was a unique specific and quite complex code because it has many functions. This is the code of the lamp that stored the emissive and non-emissive materials, which objects were these on, if the light flickered, the duration between each cycle, the number of lights. Anyway, it had a lot of information. I will also put a tutorial to handle on and off materials with lighting on them, but they were very complex and specific codes, they offer no flexibility or very little, and if we want to grow the project, they're going to be very inconvenient because we will have to keep making specific codes for each type of object. Our new system, however, is based on an event system. For example, with an event system, of which we'll also put a tutorial in the description, this event system only records in a single code all possible interaction events, which so far we have registered if the player enters or exits the trigger, if the player interacts, that is when you press the E key or the A button on the control, when you press the RB or LB buttons, that are the buttons next to the triggers above the control, or on the keyboard we have it as R or Q. These are the possible types of interaction that we have right now, and this code stores all the events. Here are all the events we have created. Then we have a code that once placed on an object, through this object you cannot trigger each of those events. For example, with the new door system, we have the general interaction code that triggers the events, one that triggers the text UI, depending on how you interact, the one that runs the audio clips, and the one that makes the door move. All of these codes are modular. We can add them or remove them from the door, and they do not affect the rest of the codes. But if you want, you can make a simpler or more complex type of interaction depending on which codes you want to incorporate. For example, based on whether the player enters or leaves, if we pressed interaction of A, RB or LB buttons in the movement code, at the time of the start, it automatically subscribes to the interactions that we want. Here we just want to know if the player enters or exits, and if it presses the A button. We are not interested in the RB or LB buttons with this type of interaction, at least not for the moment. It also saves the ID of the object. This is automatically saved by each object with an interaction code, so each object has an independent interaction ID. Then the moment an object interacts, it will send the subscribed interaction event with this ID. So only the codes that are using the same ID, those attached to the same object, will be triggered. They will trigger their functions. In this way, we have control that although there are many codes registered to the same events of dozens or hundreds of different objects, only those with the same ID will be triggered. With this, we have a lot of flexibility to grow and make our environment more complex with many different interactions and objects. Once it registers to the event and passes the ID, here we have the same functions that we use in the previous door script. That fires the moment the interaction is triggered if the player is in range. These are the same functions, but implemented in a modular system in which we can add or remove from each object without dependencies. We still have a few dependencies, but most are taken care of, and we can modulate them as we want. Likewise, with the lamp, for example, here you have the interaction code, the sound code, UI lights. Then in the lights is the same type of implementation, but based on an event subscription. When you start the code, it subscribes with an unique ID based on the object with the same functions, and if the object is destroyed, we remove the subscription to avoid errors that can occur when calling an event subscribed object that doesn't exist. The same goes for our cinematic interaction. We can choose whether it fires one or several times. Here we also want to know whether the player is or is not in the area, whether it enters or leaves, and at the moment of interaction, that the playable director attached to this object will run the cinematic. This is the script in case you want to use it. We have sound, interaction, cinematic, text and movement. Finally, we implemented an item collection system that allows us to make any object of type item a collectible item. Let me show you. This is the code that uses the interaction of the RB and LB buttons, or R and Q keys on your keyboard. If you press RB, it goes to the right hand, and if you press LB, it goes to the left hand. If there are no collectible objects on interaction range, it drops them depending on what button you press, the LB or RB buttons. But if there is an object and you press RB, in this case, then it replaces the object that was held for the new one. It is necessary to work a little more on it, since there's still an error when you are in range of two objects at the same time, and if you have both on interaction range and you try to grab them, you only grab one, but you get both destroyed. We still need to see how to fix that, so it only grabs the last one with which you made contact, but keeping the same modular system. This can be implemented to any kind of object. We can make the object we want collectible, exchange it, we can grab it or throw it. The system offers that flexibility. We just have to work a little bit on the pickup priority, but so far seems like a good start. And finally, I'm going to show you how we modified our controllers for the player and the enemies. We are currently switching to a finite state machine system, and we'll review the benefits that this system has over the unique code we used previously. The principle is the same as with the interaction events, which consist of modulating complex behaviors in smaller codes that allows us to have a little more control over errors, and thus be able to easily locate them and correct them in their separate scripts. It also allows us to have better control over the behaviors of the character and change them accordingly to the state in which he is. We have this visual representation that is the sphere above the character that changes color depending on his state. For example, if it's on idle, the sphere will be yellow and changes if we are running, jumping or crouching. Now, how can we use this? Well, we've already separated our types of interaction, and we can control the factors with which we use the character based on his states, such as with the speed. Here we can see the speed changes if we're running or if we're crouching, and currently we are using this system to implement the stealth and detection mechanic of our enemies. As we can see, if we move, a large sphere appears, around 10 meters in radius, and this is the area in which the player is producing sound. In addition to visually detecting the player, we will use sound mechanics of detection with the enemies. So the sphere will be larger if we are running, and will reduce in size if the player is crouching or moving slower. The state machine allows us that kind of freedom to change all these factors inside independent modules, so in the future we can implement more complex behaviors. With Fmod and the state machine, we will be able to change the tension of the music depending on whether the player is idle, if he got detected, if he's being chased, or if it's in combat. So it's a starting point to have a better control over our characters. And gives us the freedom to incorporate more complex behaviors. The next week we'll be refining the state machine and incorporating the player's stealth and detection mechanics with enemies. We'll be working on creating smaller enemies using this state machine, but for our part it will be all in respect to the progress of this week. We thank you very much if you have stayed with us until the end of the video, and if you like the content we invite you to subscribe and follow us on Twitter. We'll be linking the Twitter account in the description, and we will be answering any questions or suggestions. Both are greatly appreciated. Thank you very much and have an excellent day. I'm Mark from Try Hard Mode. We wish you success in your projects.